Greetings and welcome back. Today we'll be looking at a different type of substitution reactions, specifically those that start with an alcohol. Alcohols are alkanes that have an OH attached, and a substitution reaction would involve taking off something and replacing it with something else. And so for my something else, I'm just going to write our nuke, because usually we bring in a nucleophile to replace a leaving group. Problem that you might notice is that an OH is not a good leaving group. So today what we'll be doing is going through how can we kick off the OH of an alcohol and replace it with something else. Today's video will be relatively short, and I'll be giving you more problems than I give you answers, but stuff I want you to think about so that in class we can work through those answers together. So there are essentially two problems with trying to use alcohols for substitution reactions. The first problem is that an OH is not a good leaving group. And therefore, what we need to do is try to figure out a way to turn it into a good leaving group if we want to kick it off. If you look at our possible good or strong leaving groups, one of them is an O+. And therefore, it's relatively easy to turn an alcohol into an O+. We simply have to add in another hydrogen. So the best way to add a hydrogen onto something would be through an acid-base reaction, and so we could just use something like HCl. The mechanism of this reaction would be that the O could grab that H, and we could end up with a protonated alcohol. This thing right here, this O+, is a good leaving group. And that does indeed render that R group as a good electrophile. The problem is that when we have a good leaving group, the hydrogens next door are acids. In fact, they are very strong acids. And therefore, if you throw in some type of nucleophile that's also basic, instead of having a nucleophile-electrophile reaction like we'd like, instead, a lot of times you end up having an acid-base reaction. So let's say, for instance, that I want to kick this thing off and replace it with cyanide. The goal being to make a nitrile. Well, what we'd like to have happen is for that cyanide to come in there and attack the electrophile and kick off the leaving group. And that would give us our C triple bond N. Yay! All right, and we've accomplished what we think. However, this actually will not happen. Instead, cyanide is indeed a good nucleophile, but it is also a good base. And so instead what would happen is that this guy would merely just pull a hydrogen off of your alcohol. You would turn that protonated alcohol back into the alcohol you started with, in effect undoing what you just did, and as a terrible bonus, you would make hydrocyanic acid, which is the gaseous version of cyanide, which is incredibly toxic at incredibly low levels, and unless you're doing this in a hood, lead to massive destruction. So, this is a problem. We need to figure out a way to fix this. And so one thing I'd like you to think about for tomorrow is that turning an alcohol into a protonated alcohol, or an O+, doesn't usually give us the best leaving group. It does give us a good leaving group, except that it gives us a good leaving group that also has acids attached. What I'd like you to do is review the list of very good leaving groups and see if there's something besides an O+ that we can turn an alcohol into relatively easily in order to make it into a good leaving group. Because OH itself is not a good leaving group. OH with an extra hydrogen is a good leaving group. Unfortunately, it's not going to give you a lot of substitutions. Instead, it gives you a lot of acid base. So look and see what else you think would be a reasonable candidate. So there is one situation in which the information from that previous slide will be helpful. In other words, if we turn an alcohol into an O+, again, our previous problem that we do need to try to tackle is that these hydrogens are acidic, and this R is an electrophile, that O plus right there is a good leaving group. So this kind of reaction can do a nucleophile electrophile if we have a nucleophile that is not basic. So again, the problem on the previous slide is that most of our nucleophiles are also strong bases, and they'll do acid-base first, and you won't actually get a substitution. But what do we have that are nucleophiles but not bases? And the answer to that is halogens. So we have Cl minus, Br minus, and I minus, and all of these guys have lone pairs and negative charges, but they are not going to be bases, and therefore, theoretically, all of them will let us do a substitution reaction and kick off that O+. They won't react with the acid because they're not bases. Therefore, instead, theoretically again, what they'll all do is attack that R and kick off our leaving group and give us a lovely new alkyl halide. Alright, so here's the issue. That works pretty well for Br minus because Br minus is a pretty good nucleophile. Unfortunately, it doesn't work very well, and we get pretty low yields. The same thing for Cl minus, except that Cl minus is an even worse nucleophile because it's less polarizable, and therefore Cl minus almost doesn't work for this at all. I minus is okay. We don't seem to get a lot of reaction out of that one either. So unfortunately, while this can work, it doesn't work very well. So what I'm going to do for you tomorrow is I'm going to give you the reagents that we use in order to convert an alcohol into an alkyl halide. And I'm going to ask you guys together to work out how that mechanism occurs. So the only way to prepare for that, and what I would like you to do, is review how to spot a good leaving group, an electrophile, a nucleophile, an acid, and a base. All right. Thank you very much. In essence, I'm asking you guys to do some thinking before class and not work out a lot of problems. I will see you soon, and we will work some things out together, so bring your thinking cap to class. Take care.